Okay, let's try this again now that my other loads aren't on the inverter. The lathe is set up for 60 RPM. The diamond saw here is set up for about 8,000 or 9,000 RPM. I don't know, it's fast, and we're going to use water as a lubricant. Were we cutting off a long piece instead of this chipped end, we'd be running a rod up inside the glass to catch the falling piece when it cuts. You'll notice the saw is at a little bit of an angle. That's so this block over here won't hit the glass and break it off before we're finished cutting through it when it's sticking past the block. So here we go. We turn on the saw, and we turn on the lathe, and we bring it up to close contact, and cutting. We want to use some water both to keep the diamonds on the wheel and to keep things cool. And we'll set up the Infeed. This is pretty much a one-handed operation. I'm simply holding the eyedropper against the end of this, and capillary action actually doesn't have to keep it wet. The other reason we're keeping it wet is to keep silicone dust out of the air. As you can see, we did a nice job. We're going to let it run in a little bit. And it's in nice and smooth. And we're done. So we stop the Infeed, stop the lathe, stop the saw, back it out, and here we have a perfectly cut end of quartz that you can't tell is perfect because of the drops of water on it, but it is. We will later flame anneal the ends of this to make it a little less brittle in use, because this is going to be part of a high voltage feed through and it's going to see some funny conditions. Okay, now I'm going to cut the real piece. I just cut the chipped nasty end off.